So guys, welcome to our channel once again. In today's video on our WAEC physics exam revision series, we have here these 10 physics repeated questions to answer on the topic electric field. So guys, this video will be about electric energy and power, so ensure to stay till the end of this video. So let's go ahead and start with the first question here. It says a lamp is rated 240 volts 60 watts. Determine the resistance of this lamp. So guys, actually it's very simple to calculate this using the formula I is equal to V squared over the power. So the voltage here is 240. When we square 240 here, we divide by the power, and guys, that will give us 960. So guys, the answer to this question is 960 ohms, and that's option B here. So option B is the answer to this question. Let's go ahead and wipe this off, and then let's consider the next question, guys. So guys, that's question number 2 here. It says a charge of 10 coulombs is transferred across a potential difference of 220 volts. Calculate the work done. So guys, actually we can calculate the work done using W for work is equal to Q times V, where Q is the charge and V is the voltage. So when we calculate this, we're going to have 10 here, which is the charge, times 220. So W is this, and then this will be equal to 2200 joules. So the answer to this question here is option D. So that's it for this question. Let's go ahead and wipe this, and then let's consider the next question, guys. So that's question number 3 here, guys, and the question here says an electric lamp is rated 240 volts 40 watts. What is the cost of running the lamp for 72 hours if the electricity automatically charges 2.50 naira per kilowatts? Alright, so guys, actually what we need to do here is actually check what 40 watts is in kilowatts. So since this is 40 watts, in order to convert it to kilowatts, we divide it by 1000, and that's 0.04 kilowatts. So since this is 0.04 kilowatts, the total cost of this will be 0.04 times 72 times 2.5, that's 2 naira 50 kobo whatsoever. So this will be 72, which is the time, 72 hours, then times this power here, that's 0.04 kilowatts, then times the charge per kilowatts, that's 2.50. and guys, when we multiply all these together, we're going to have 7.20. So that will be option D here. So we have 7.20 naira here as the total charge. So that's it for this question. Let's go ahead and wipe this, and let's consider the next question, guys. That's question number 4 here. So the question says an electric heater has a resistance of 50 ohms. When it is immersed in water and connected to main source, it draws a current of 4 amps. Calculate the heat gained by the water if the heater is switched on for 2 minutes, assuming no heat losses to the environment or to the surroundings. So actually guys, here the heat gained by the water will be calculated as I squared RT. So already we have the current here, and then we also have the time in minutes, so we'll convert it to seconds, and then we have the resistance here in ohms. So the current here is 4, so we are going to have the square of this 4, then times the resistance, which is 50 ohms, and then times the time is 2 minutes, and 2 minutes times 60, that's 120 seconds. So guys, let's multiply this out. We're going to have 96,000 joules. Wow, so this is 96,000 joules, and that's the answer to this question. So let's go ahead and wipe this off, and then let's consider the next question, guys. So guys, the next question we have here is question number 5 here. It says the voltage and current in the primary of a transformer are 200 volts and 2 amps respectively. If the transformer is used to lighten a 12 volts and 30 watts bulb, calculate the efficiency. So guys, this is how we are going to calculate for the efficiency. We are going to have the efficiency to be the power for the secondary over the power for the primary, then times 100%. So guys, the power for the secondary here will be actually 10 times 30, since we have here that the transformer is used to lighten 10 of this 30 watts bulb. So in that case, that's 10 times 30, and that's 300 watts over the power for the primary. So let's take note that we don't have any wattage here for the primary, but we know that power is voltage times the current, so that's 2 times 200, and that's 400. So this will be multiplied by 100%. So when we do 300 over 400, that's 0.75. when we multiply this by 100, we'll have 75%. And that's it for this question, guys. Let's go ahead and wipe this, then let's consider the next question. That's question number 6 here. It says a lamp rated 100 watts 240 volts is light for 5 hours. Calculate the cost of lighting the lamp if 1 kilowatt hour of electricity energy costs 5 naira. So 1 kilowatt hour will cost 5 naira, and actually a lamp that is 100 watts 240 volts is light for 5 hours. So guys, in order for us to calculate for this, we're going to have that the energy consumed here will be the power times the time. But let's recall that here the power here is actually supposed to be converted to kilowatts, so that we can have everything in the same unit. So 100 watts, which is 0.1 kilowatts, times the time in hour to get it as 0.5 kilowatt hour. So now that we have 0.5 kilowatt hour, so we are going to check what will be the cost for the lighting. So since we have 0.5 kilowatt hour, we are going to multiply this by the cost, that's 5 naira, and we are going to have 2.5 naira, and that's the answer to this question. So let's go ahead and wipe this off, guys, and then let's consider the next question. So that's question number 7 here. So this question here says electric resistance is a property of an electrical conductor that causes electrical energy to be converted into A, magnetic energy, B, heat energy, C, chemical energy, D, mechanical energy. So guys, the answer to this question is option B, and that's heat energy. So let's go ahead and consider the next question. So that's question number 8 here. It says, which of the following devices converts heat energy to electrical energy? We have A, transformer, B, thermostat, C, thermocouple, D, dynamo. So guys, the answer to this question is option C, and that's thermocouple. So let's go ahead and consider the next question, guys. That's question number 9 here. The question says electrical energy is measured in A, kilowatt hour, B, coulomb, C, kilowatts, D, ampere. So guys, the answer to this question is option A. Electrical energy is measured in kilowatt hour. A kilowatt hour is a unit actually of energy that is equivalent to 1 kilowatt of power expended for 1 hour. So that's it for this question. Let's go ahead and consider the next and last question, guys. So that's question number 10 here. It says the maximum power dissipated by a 100 ohm resistor in a circuit is 4 watts. Calculate the voltage across the resistor. So guys, in order for us to calculate this, we have to first of all state that the power is voltage squared over the resistance. So the power here, since the power is voltage squared over the resistance, so the voltage squared now is going to be the power times the resistance, but then voltage alone is going to be square root of the power times the resistance. The resistance is given, the power is given, so V now is going to be square root of 4 times 100. So guys, this will be actually square root of 4 is 2 and square root of 100 is 10. So V is equal to 2 times 10, and that's 20. So this will be 20 volts, and that's option A here. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section and we'll ensure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community where we post major updates on WAEC examination. So this will help you a lot even as you prepare for your WAEC examination for the year. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.